sorry, wrong session. I was sitting down for session 4. No, this is session 3 of the board. Say you have a string of symbols. Okay, it could be a mix of variables and terminals. So a mix. And let's label these strings U, V, and W. These mixed, let's say mixed strings. They don't have to be mixed. They'll be, well, yeah, keep it simple. They're just a mixed string of symbols that are variables and terminals. U, V, and W. Okay. Now, so we have a rule, substitution rule of this form. So here's your. Now remember, in a substitution rule, the left-hand side is always a single variable. It has to be a variable. It can't be a terminal. So say you've got a substitution rule of this form. So A arrow W. Now remember, U, V, W. W is a string of. Well, you have 3 possibilities actually. W could be a string of terminals. It could be a mixed string of terminals and variables, or it could be a string of only variables. So, okay, strictly speaking. Okay, so that's one of your rules. In other words, substitution rules of your grammar. Okay. Now, if what you have currently written is of this form, so U, A, V, that's why we're talking about U, V, and W, you can rewrite that by substituting the A for W. So you'll replace this A with W. Okay? So this gets rewritten, the A gets substituted by W. Okay? So this becomes this. Okay? That's why we talk about a U, V, W. Right? So that is said to yield, that's the verb. In ordinary English, to yield in this context would be to provides, gives, yeah. So this yields that. Think of that as leading to, or gets substituted for, or becomes, or is overwritten to. I mean, many ways you can say this. Okay? So this yields that. Why? Because you substituted A for W using this rule, this substitution rule. Okay? So that yields that. All right. Now you can say a string, if you like. Typically, it'll be a mixed string, a mixture of terminals and variables. So this string derives V, and you can write that this way. And this is usually the implied, almost like the therefore. With a star. So that star meaning multiple steps usually. Okay. So if you can derive starting with U V. Okay. Using multiple steps. Now you can do that. That V just equals U, or U equals V. Right? You just go there. Well, but you don't do anything. It's just there already because U equals V. Or if there's a sequence of between U and V, there's a sequence of other strings where, for example, U1, U2, ... UK, so that U yields U1 and U1 yields U2 and so on. Yields UK, which yields V. Right? So if that happens, so this yields that one yields that one, and so on, then you say that U derives V. So this would then be your derivation. Okay? The derivation of V from U, or put with the emphasis the other way around, you say that U derives V. Okay. Now with those terms, the idea of deriving, one string derives another, and this string, like a mixed string, yields another string. With those terms, we can now redefine a language of a grammar. Remember what that means? The language of a grammar, L of G, is the language that the grammar generates. That grammar will generate a whole bunch of strings. Those strings are the members of the language. Okay? So a language is the set of strings generated by the grammar. Okay? That grammar, the language is just a set of strings. Okay, so these strings are W, and they will belong to capital sigma starred. What does that mean? Well, that set there is the set of all possible strings of terminal symbols. Okay, that's the set of all possible strings of terminal symbols. That's there. Right? So you're but with the condition that starting with your S, the start symbol of your grammar, you can derive, that's this, right? You can derive that string, W. And W is a string, all of whose symbols are terminals. Because that, W belongs to that. So this W must be a terminal string, if you like. All the symbols in that string are terminal symbols. Okay. So what you're saying here, this is the set of strings that you can derive from the start symbol. Or another way of saying the same idea is it's a set of strings that are generated from your grammar. This is a bit more specific. This is saying this is a string that's generated from, or is derived from the start symbol. And that start symbol is one of your four terms in your for tuple, which is the formal definition of your grammar. Okay, does that sort of make sense? Okay. So your language is just a set of strings, and all those strings you generate from your grammar. All those strings are derived from, using this sort of sequence of derivation like this, derived from the starting state, S, of your grammar. Okay? Alright. Well, let's write out the formal definition of grammar G1. Okay? So, now remember, formal definition of grammar is a for tuple, the four terms, V, capital sigma, R, capital R, and capital S. Okay, so capital V is what? It's the set of your variables, your variable symbols in your grammar. Well, for G1, if you remember, we only had two, it was A and B. Okay? And we only had three terminal symbols. They were 0, 1, and hash. Okay, so that's your capital sigma. Let's change the order a bit. Okay. The starting symbol, that was the fourth term before, but now I guess because it's easier, shorter. So the start symbol for G1 was just A. Right? And the set of rules, the substitution rules, there were three of them in this very simple grammar. Here's one of them. Now remember, the left-hand side of a substitution rule is always a variable. It has to be a variable. And just one variable. Right? It's a context-free grammar. Now later, when we have non-context-free grammars, you may have more than one symbol on the left-hand side. And then you can imagine the grammar becomes much more complex. Okay? So, in general, context-free grammar is much easier to deal with They're much less involved, complicated than context-dependent grammars, where what's on the left-hand side of your substitution rules would have more than one symbol. Okay, but I'm jumping way ahead. But you keep hearing this term context-free. So what does that mean exactly? Okay, all right. So here are your three rules. So from A arrow you substitute A for 0 A1, or you substitute A for B, or you substitute B for hash. Okay, there are your three rules. All right. So that's the formal definition of the grammar G1. How about grammar G2? A bit more complicated. So again, what's your V? The set of variables. We had 10 of them, wasn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's your set of the variables for the second grammar, grammar G2. The terminal symbols, how many of those did we have? Well, we had the normal Roman alphabet, so 26 letters, and we had a space. I've represented the space here by I don't know how you call it. I don't even know what the label is for that symbol, like this. But that's conventionally used to represent a space. It's interesting. I've never thought about giving. What is the word for that symbol that looks like a sort of bucket? This kind of. What do you call it? I'm 65 years old and I've never even thought of it. It's amazing what comes up in the lecture. Alright, okay, so that's the 27th symbol, right? The ordinary alphabet. So you have 27 terminal symbols in your set of terminals. Okay? So this thing, whatever this is the blank symbol, right? And you need the blank to separate words. And what's a word? Well, it's just a string, if you like, substring of terminal symbols without the blank. And the blank is used to separate words in the ordinary English sense of the meaning, like contiguous symbols taken from the Roman alphabet, those 26 letters. Right? Now, a bit of a comment now. Often a grammar, in practice, specifying a grammar or writing it out, in practice you tend only to write out the rules. Instead of writing out a four-tuple, you tend to only write out, in practice, you tend to write out only the R. And why is that? Well, because you can quite readily deduce the other three from the rules, from R, big R, the set of substitution rules. And why is that? Well, think about it. Okay, so you're given R. So what are all the variables? So you're now trying to create, deduce what the set V is, big V, the set of all the variables. Well,